Hello, this is Chitran from Just Tutors. Today we are going to learn about equations of motion. So the objectives of this video are equation of motion by graphical method, uniform circular motion. So let's move ahead. Here are some pre-assessment questions prior to this topic. Let's try these questions. You can check your answers on the next slide after trying these questions. Here are your answers. Very well done for your efforts you made in trying these questions. Keep it up. Let's start our learning for this video. The very first is first equation of motion. So let me tell you that there are three equations of motion, and we'll start learning from the very first equation of motion. As we know very well that acceleration is change in velocity over time. So we can denote acceleration by small a. Change in velocity is difference between the final velocity and the initial velocity. So initial velocity is represented by small u and the final velocity is denoted by small v, and we have used small t as time. So v is in meter per second, means velocities are taken in meter per second and time is in second. So from this equation we get at equals v minus u, and it gives, when we transform or exchange them, so we will get v is equal to u plus at, which is very first equation of motion. So let's try this example. A car changes its speed from 10 meters to 20 meters per second. Calculate the acceleration for 5 seconds. So as a car has started from this velocity, so it will be initial velocity, so we can say it u. So it will be u, your initial. This is your final velocity, it will be v, and for 5 seconds so it will be t. So we can substitute all these values as we need to find out acceleration. So we'll put substitute all values in this formula. So a will be, that is acceleration, 20 take away 10 over 5. So this will give you 10 over 5, and by this you will get 2. And remember, the SI unit of acceleration, it is meter per second square. So here's the answer for this example, and you can try or use all equations of motion in similar way. Let's move ahead to the second equation of motion. So we have a graph for motion. So let's take a situation where object covers a distance s. So distance covered is small s, or we can say just s, and in time t under uniform acceleration. So if you look at this graph, we can see this is time represented here, this is velocity v, final velocity, and this is initial velocity u. So by working on this graph, we can say distance traveled is area of the figure OABC. This is OABC. So we can find out the area of this shape by finding area of OACD, which is a rectangle here, OACD, and then area of triangle ABD, this one. So area of it is OECD is OA times OC. So OA we have is small u, we can substitute the value u. OC is small t, so we get ut here. Now half OC is again t, so we'll get t, and BD is, so this is BD. For working out this BD, we can take away CD from the whole BC. So BC is whole in all V, and BD is U. So we have to take away U, V minus U, and from the very first equation we remember V minus U is AT. You can have a look here. See, V minus U is 80, so we can write 80 in place of BD. So we get this. On working out, we'll get the distance traveled is small s is equal to ut plus half at square, and this is just second equation of motion. Now let's move on to third equation of motion. From the same velocity time graph, distance traveled by the object in the time t and moving under uniform acceleration a is given by the area enclosed by OABC, this whole one. So how can we work out for this? Again, s is distance traveled, OA plus BC times OC. So by this we can get s is equal to v plus ut over 2. So the first equation of motion is v is equal to u plus at, or we can say time is equal to v minus u over a. So substituting these values in this one, s is equal to v plus u, v minus u over 2a. So we'll get v square minus u square over 2a, and it gives us 2as is equal to v square minus u square, which is your third equation of motion. Now, uniform velocity. So a body has a uniform velocity if it travels in a specified direction in a straight line and moves over equal distances in equal intervals of time. The velocity of a body can be changed in two ways. The very first is by changing the speed of the body, or by keeping the speed constant but changing the direction. Then it comes average velocity. So average is really easy. You can use the formula for average. As we have two velocities here, the one is initial, the second is final, so adding them both and dividing by 2 will give you the average velocity. Then the next is retardation, deceleration, or negative acceleration. It is same as acceleration. In acceleration we say that the speed or the velocity will increase, but in retardation it is same as acceleration but a negative impact. In this, the velocity or the speed of an object decreases. So we can say a body is said to be retarded if its velocity is decreasing. Retardation is measured in the same way as acceleration but with a negative sign. For example, when a car driver traveling car at an initial velocity of 10 meters per second, and due to some reason he need to apply his brakes and brings car to the rest in 5 seconds, the final velocity becomes 0 due to the retardation produced by brakes. You must have experienced this. Now here are some practice questions. You can try these questions on the basic facts which we have just learned in this video. You could pause the video and try questions, and after that, as we always do, check your answers on the next slide provided for you. Here are your answers. If all your answers are correct, good, very good, keep it up. And that's all for this video. For more videos, you could log on to justtutors.com. Thank you.